Hello, this is Liz here from Maths for Granted, and today we are going to be looking at highest common factors and lowest common multiples, where we just go about listing them. We will be looking at another method later where we use something called prime factorisation, but first we're just going to be using lists. Okay, so let's have a look what we've got here. Danny wants to buy hot dogs and hot dog buns. So we're basically buying sausages and bread rolls. He doesn't want any extra hot dogs or rolls. How many packets of each should he buy? So every time he buys a packet of sausages, he gets 6 sausages. Every time we buy a pack of bread rolls, we get 4 bread rolls. So we've got to work out how many packets of each do I need to make a certain amount of hot dogs without having any sausages left over or any bread rolls left over. So for example, if you bought 1 packet, you'd have 6 hot dog sausages, 2 packets, 12 hot dog sausages. If we buy 1 packet of bread rolls, you've got 4, 2 packets, you've got 8, 3 packets, we've got 12, and then this is the answer I've got. So I've found the first number here, where I would use all of my sausages up and I'd use all the bread rolls up and I'd get exactly 12 hot dogs. Okay, so we'll think what we've done shortly. Let's have a look at another one. Zach sees the 95A bus and the number 17 bus at the same time at the bus stop. A 95A arrives every 10 minutes, a 17 arrives every 15 minutes. When will Zach see both the 95A and the 17 at the bus stop again? So the method we're using is just sort of listing them. So let's think of the 95A. So the next bus he will see will be in 10 minutes time, then obviously 20 minutes, then 30 minutes later. Whereas the 17 only comes every 15 minutes. Okay, so imagine he's literally just saw them together and now he's going to have to wait another 15 minutes for the next number 17 and then 30 minutes for the number 17 after that. So we've spotted again, I've got the same number appearing in both, so it will be 30 minutes time before both buses can be seen at the bus stop at the same time. Okay, one more. Mary takes her dog for a walk in Whittingham Park every 6 days. Paul takes his dog for a walk in Whittingham Park every 8 days. They see each other there at the park on Monday. How many days will it be until they see each other again in the park? So let's look at Mary to start with. So obviously 6 days later she will go to the park, and then 12 days later, 18 days, 24, 30. So I'm just going up in the 6 times table there. And then with Paul, so after that Monday it will be 8 days later before he goes again, then 16 days, and then 24 days. So hopefully you've spotted 24 there appears in both of those times tables. So in fact, before they see one another again, it will be 24 days later. So sort of after that Monday, it's sort of 3 weeks and 3 days. So sort of a Thursday, I think that would be, isn't it? So quite a long while later. So what we've actually found there with all of these examples is we've been looking at finding the lowest common multiple. And we often use that when we want to try and find out in real life situations when events will be happening at the same time again. Okay, so lowest common multiple simply means lowest, obviously means smallest. Common means shared, they've got this number in common, and we know multiple means it is in a numbers times table. So one method of finding the lowest common multiple is to list your 4 times table and to list the 5 times table, and we're looking for the smallest shared number. So we can see clearly 20 is the first number they both hit that is in both of their times tables. So the lowest common multiple of 4 and 5 is 20. Here's an example of 4 and 6, lowest common multiple. So look, I'm doing my 4 times table, 6 times table, and 12 is the first number, the lowest number that appears in both tables. Let's have a look at the lowest common multiple of 8 and 6. So we'll do a few of our 8 times tables. We'll do a few of our 6 times tables, and can you see there, 24 is the first, the lowest number that they have in common in their times table. So the lowest common multiple of 8 and 6 is 24. Okay, so those examples were all looking at finding lowest common multiples. I'm now just going to show you some examples of some sort of practical real life questions that we will be looking at now, highest common factors. So we'll look at a couple of examples. A carpenter has 2 pieces of wood. One is 21 centimetres long, the other is 35 centimetres long. Using both pieces, they want to make as many equal length pieces as possible. So we don't want any waste, we don't want any bits left over. What is the longest length pieces they can cut and not waste anything? So let's start with the 21 centimetre bit of wood. So obviously I can cut it into lots of little 1 centimetre pieces. I could cut into 3 centimetre pieces and there'd be nothing left over. I could cut into 7 centimetre pieces and there'd be nothing left over. Or I just leave it as one long piece of wood. Let's have a look at the 35. You could cut it into lots of little pieces. 5 centimetre pieces, you wouldn't have anything left over. 7 centimetre pieces, and or you just leave it as one long bit of wood. So remember the question was, what's the longest length piece that they can cut and not waste anything? So in fact, I want the same length piece from both pieces of wood. So you can see there the number that appears there, the highest number is 7 centimetres long. Okay, let's have a look at a couple more. We've got an outdoor activity club. There are 30 boys and 24 girls. Groups need to be made with the boys split equally between the groups. Yeah, so I've got to have the same number of boys in each group and I've got to have the same number of girls in each group. What's the maximum amount of groups we can make? Okay, so let's see if we can get our head around this. So we've got to try and think of all the different ways we could split up the boys, and then all the different ways we could split up the girls, and we want the same number of groups because then they're going to be put together, aren't they, the boys and the girls? So you could have one big group of 30, but of course I haven't really split them up at all. 2 groups of 15, 3 groups of 10, 5 groups of 6, 6 groups of 5. Hopefully you've spotted these are all factors of 30, aren't they? 10 groups of 3, 15 groups of 2. Or I could have 30 groups of 1, but I suppose you'd argue they're not really groups, they're on their own. Let's look how the girls can be split up. You could have one big group of 24, but then we haven't really split them up at all. 2 groups of 12, 3 groups of 8, 4 groups of 6, 6 groups of 4, 8 groups of 3, 12 groups of 2, or 24 little groups of 1, but they're not really groups because they're all on their own. So we want the biggest number of groups and we want the same number appearing there. So can you see we could have 6 groups of 5 boys and 6 groups of 4 girls. So each group would then have 5 boys and 4 girls in, and there'd be none left over. There'd be no boys or girls left over. Okay, let's look at one more. A charity is making emergency supply boxes. They have 36 rolls of toilet paper and 45 toothbrushes to be split equally between boxes. What's the largest amount of boxes they can make? So the clue is we want the largest here, just like we wanted the largest amount of groups on the previous one and we wanted the largest piece of wood on the one before that, and we don't want any left over again. So let's start with the toilet roll. So I could have, for example, just one box with all 36 toilet rolls in, 2 boxes with 18 in, 3 boxes with 12 toilet rolls, 4 boxes with 9, 6 boxes with 6. You get the idea that these are all the factors of 36 again. Let's have a look at 45. It doesn't have quite so many factors there. So look, I could have one big box with all 45 toothbrushes, 3 boxes of 15, 5 boxes of 9, 9 boxes of 5. So I want the biggest amount of boxes. Remember, it's got to be common to both those. So hopefully you've spotted the biggest number of boxes common to both was the 9. So in each box, in each of those 9 boxes, you'd have 4 toilet rolls and 5 toothbrushes. So what we've been doing there, we've been finding the highest, we've been finding the largest, haven't we? Common, shared, and we've been finding factors of both numbers in those examples. So we are going to be looking at highest common factors. So what we do is we list the factors of each number and then find the largest factor in both lists, because it's got to be common to both. So let's look at the factors of 18. We'll do them as pairs because it's easier. So 1 and 18, why list them as pairs? Because it helps you remember if you've forgotten any. 2 times 9, 3 times 6. That's all the factors of 18. And then 12, you can have 1 times 12, of course, 2 times 6, 3 times 4. Now you're looking for a number, the biggest number that is common to both of those lists. So hopefully you've spotted the biggest number is 6. So the highest common factor of 18 and 12 is 6. So here's one done for 16 and 20. So I list my factors of 16. Hopefully you've noticed 4 doesn't have a partner because I'd need 4 times 4 here. So I've got an odd number of factors because 16 is a square number. And we've got 6 factors here, and the biggest common factor is 4. Let's look at the highest common factor of 36 and 60. So let's do our factors of 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, and of course you can have 6 on its own, 6 squared. Factors of 60, there's a lot, I'm afraid. You could have 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. I think we've got them all there. And can you spot the biggest number, the largest number that is common to both of those lists? Hopefully you spotted it was 12. So the highest common factor of 36 and 60 is 12. So we've covered the lowest common multiples and highest common factors just by listing. So I'll do another video where we use a different method that you may prefer. And thanks to Go Teach Maths for that particular PowerPoint that I've used. See you soon. Bye.